All right, the LCM. Okay, now we have went over the greatest common factor. Okay, and we tomorrow we're going to go over the LCM. Now I'm going to switch back and forth between the two so you can see them. Okay, because I think this is important. Remember when we talked about, or remember at the end of the GCF, we showed you something called a Venn diagram. Remember that? Okay. You might like that way better when it comes to the LCM. I don't know, but I'm going to show you multiple ways of how to do this. Okay. Meaning the expanded form, the exponential notation form, and the Venn diagram. Sometimes the Venn diagram, you're going to find out whether you like it or not, it is easier finding the GCF and the LCM. Kind of organizes it better. Okay, but again, I'm going to show you several different ways. You pick which way works best for you. Right? That's the beauty of this. All right, the LCM, what does it mean? All right, so least common multiple. That is correct. Now, when we talked about the GCF, what kind of a number was that? Big or small? Big or small? It was small. Remember, it was deceiving when it said greatest common factor, right? Everybody thinks, oh, it's got to be a big number. Okay, well, actually, it's a small factor. It's a small number. It could be 2, could be 4. Okay, when you talk about the least common multiple, this is generally going to be a big number because multiple means to multiply. Okay, so you're going to have to find a small, in the sense, factor that the two numbers divide into evenly. So again, remember the greatest common factor in the LCM, they kind of play tricks on your brain there. Biggest or greatest means actually it's going to be a small number. Least, right? We think of a small number, least, something small, but it's actually going to be a big number. All right. Let's define this. Definition. Hey. Here we go. All right. First number that a pair or trio, right? And we'll do some of those, right? A pair meaning 2, trio meaning 3. Of numbers goes into evenly. Right? And again, that means that we're dividing. Everything has to go in evenly. So far, so good? All right. Let's try a few. So we'll start off easy. We have 15 and 9. Okay, and again, just just remind yourself that the directions, remember, some of them will say list all the factors, some of them will say use a Venn diagram, some of them will say prime factorization. I don't care which way you do it, but I'm going to, as long as you show me like you did the other day on your quiz. Okay, so pick a way that works best for you. All right, and again, the beauty of this is, do you have to know all of the factors? No, you don't. Right, so we'll factor 15 to be 3 and 5. We'll factor 9 to be 3 and 3. Okay, so we're going to bounce back and forth between these because you already know how to do the GCF. Okay, the GCF was what? What they share in common, yes? Okay, so they have a 3, right? And that's the only thing they have in common. Okay, so the greatest common factor was 3. Now, to find the LCM, this is where you got to do a little bit more math. Okay, if they're listed this way, we still put what they have in common. Okay? You take one of them, and then you write down what else they have. Right? There's a 3, right? This 3, and they have a 5 left. So the smallest number that 15 and 9 can divide into evenly is 45. Does that make sense? Yes or no? Okay, now watch this. I want to change this up a little bit. So again, we have 3 and 5, right? And over here, if we put it in exponential notation, you might like this way. So pay attention, right? 3 squared, right? Because we have 2 3s. Okay, so if you do it the exponential way, to find the LCM, you always take the exponent that is higher. See, because this is always 3 to the first power, right? If you just have one of them. Okay, so the bigger one is 3 squared. You always take the larger exponent. Okay, because this 3 really isn't that part of that 3 right there, right? And then whatever is left, you multiply it for the LCM. So again, you still get 45 that way. Does that make sense? You always take the larger exponent. So far, so good? Okay, now, personally, I like the Venn diagram. Watch. Whoa, hey, what happened there? Watch this. And again, we'll use our numbers, 15 and 9, right? We got 3 and 3 over here. We got 3 and 5 here. Watch this. What do they share? They share a 3, right? So that goes in the middle. Right? So we use the 3, we use the 3. We have a 5 left over here, yes? Okay, then that goes in that circle. We have a 3 over here. That goes in that circle. This is why I like the Venn diagram, because it's kind of foolproof. Okay, so in the middle, we already know that this is the greatest common factor because that's what they share together, right? Okay, to watch this. This is pretty neat. To find the LCM, guess what you do to all of the numbers that are in? What do you think you do to all of those? You multiply them. So you multiply 5 times 3 times 3, and guess what? That still gives you 45. That's why I like the Venn diagram, because whatever is in the circles, you multiply together, and that's your LCM. Does it make sense? Okay. Everybody good with that so far? All right. Let's try another one. So let's try 8 and 12. So we'll say 4 and 2. We'll say 2 and 2. We'll say 4 and 3. And we'll say 2 and 2 over here. So far, so good? Right. So watch this. We'll do it exponentially. So we have 2 to the third. And here we have 2 squared times 3. Okay. If you're doing it exponentially, you always take the larger exponent, which means we're taking that one. 2 to the third, right? What do we have left that we didn't use? The 3, because those two are, right? We're always taking the larger exponent. So these are already used up. So what's 2 to the third? 8. Very good, whoever said that. Times 3. So the smallest multiple that 12 and 8 can divide into evenly is 24. Does that make sense? You're not finding factors like the greatest common factor. You're finding the smallest multiple that those two numbers can go into. Okay? Let's do this. Look at the Venn diagram. What do they share? They share 2 2s, yes? That means we got one extra 2 over here and we got a 3 over there. Right? This is why I like this, right? What's 2 times 2? 4. What's 4 times 2? 8. What's 8 times 3? 24. You still get it. You multiply all of the numbers in the Venn diagram. How many of you like that way? I'm just curious. Yeah, I do. I mean, it's as long as you factor down the prime, right? And you get the numbers in the right circles, it's foolproof. Okay. So far, so good. All right, let's try another one. 14 and 22. Okay, so we have 2 and 7 and 2 and 11. Okay, again, you got to be careful here. We're finding the LCM. So what's the larger exponent? They both share a 2, but which one's larger? They're the same, right? It's 2 to the first power. So you take a 2. They're the same. So you're only taking 1. We have a 7 in that tree, an 11 in that tree. You multiply them together. Uh-oh. 2 times 7, 14 times 11 is 154. That is the smallest multiple that 12 and 20, I'm sorry, 12, 14 and 22 can go into evenly. See how we're getting to be a large number now? A factor here would be 2. See what I'm saying? Okay, but now we're dealing with the least common multiple, the smallest number that they can both be divided into evenly. You got to be able to switch your brain back and forth between greatest common factor and the LCM. So far, so good. Okay. Now, let's do this because we like to do this. Let's do this into a Venn diagram, right? Same thing. They shared a 2, a 7 was over here, and 11 was over here, right? This was 14, this was 22. Okay, so again, from the Venn diagram, what is this right here that they share? I know, but what is it? You're right. What is it called? That's the greatest common factor. See how easy this is from the Venn diagram? To get the LCM, you take it all. 2 times 7 times 11 gives me 154. Making sense? Yes? All right. Let's try 8 and 26. You try that one on your own. However you want to do it the exponential way, do it that way. You want to use it doing the Venn diagram, do it that way. I'll give you a minute or two to figure that out. All right, how do we factor 8? What do we use? Lazar? Very good, sir. How about 26? Colleen? Very good. Okay, so if you did it the exponential way, you would get 2 to the third power, right? Over here, you just get 2 and 13. So if we were finding the LCM, you would take the largest exponent, right? And then you would take the 13 because that's what's left. Does that make sense? All right, so 2 to the third power is what? 8 times 13. That is correct. Very good. The smallest number that 8 and 26 go into evenly is 104. See how that's not a small number, right? If we were doing a Venn diagram, watch this. Okay, what do they have in common? They have a 2. Over here, you would have another 2 and a 2, and over here, you would have 13. So, what is the greatest common factor? Look how small that is. The greatest common factor here is 2. That's a small number. And to get the LCM, then you multiply them all together to get your 104. See the difference between the two? All right, let's try another one. How about 16 and 28? I'll let you do that one on your own as well, and then we'll get into triples. All right, ready? Ready? Okay, how do we factor 16? 4 and 4. Okay, that's fine. How about 28? 14 and 2. That's fine as well. 7 times 2. Okay, couple ways. So we can say 2 to the 4th, 2 squared times 7, right? If we were doing it the exponential way. Which is the larger exponent? 2 to the 4th. So you're taking 2 to the 4th, because that assumes that, times 7. What's 2 to the 4th? 16 times 7. 112 is the LCM. Now, can you use your Desmos calculator to multiply these numbers? Yeah, I don't care. It's fine. I want you to get it right. So 2 times 2 times 2 times 2 times 7. Let the calculator do that. It's fine. Okay, if we were doing this using the Venn diagram, right? And here is where maybe you need to write out in expanded form so you can see what they share, right? They got a 2 and a 2 and a 2 and a 2. So what goes in the middle? 2 times 2. That's what they share, right? Okay, over here, what they don't share is you have another 2 2s. And over here, you have a 7. And when you multiply all of those together to find the LCM, you get 112. I'm just curious, how many of you like the Venn diagram way? Just curious. Yeah, I like it too. It's really nice because it's everything in one place. All right, everybody good with 2 numbers? Sure we can. We can do that. Okay, let's try 10 and 46. All right, ready? All right, I'm assuming we did this. Pretty easy, right? What did you do for 46? 2 times 23. That is correct, right? When all else fails, if it's an even number, divide by 2, right? All right. What's the highest or the largest, I should say, exponent? They're all the same, right? 2 to the first. So we take a 2. We got a 5 here and a 23 there. So what do we get? 230 is the smallest number that 10 and 46 go into evenly. See how the numbers are getting bigger again. The LCM is usually a larger number. Okay, if we were to do the Venn diagram, again, what do they share? They share a 2. You got a 5 here and a 23 here. This is the nice part about it. The greatest common factor is right there in the middle. If they were to ask you to find the GCF, boom, right there it is, 2. To find the least common multiple, then you multiply everything inside the Venn diagram and you get your 230. All right, we ready for triples? All right. So let's do 10, let's do 12, and let's do 14. Now, we'll do this together, but here's what I want to tell you with triples. The first thing that you want to do is look at the 3 numbers. Hopefully you're listening. If the 2 smaller numbers go into the largest one, guess what you've just found? The least common multiple. You don't have to do anything. If the 2 smaller numbers go into the biggest number, then the biggest number is the least common multiple. You're done. You don't have to factor anything. Okay? 10 doesn't go into 14, neither does 12, so we have to factor. All right, so we'll make this easy. We get 2 and 5, 6 and 2, 2 and 7. Now, unfortunately, I do not know a way that the Venn diagram works for 3 of them. This just doesn't work that way. All right, so watch how this works. So again, we're finding the LCM. First thing I would do, what do they all have in common? Okay, so we put down the 2. Okay, and I don't know if you want to X those out or whatever because you used them. They all have to have the same thing in common, right? Okay, so a 2. What do we got left? We got a 5 over here. Let me put that in a different color. We got a 5. What do we have over here? We got a 2 and a 3, right? So we got a 2 and a 3. And over here, we got a 7. You got to multiply all of those together to get the smallest multiple that 10, 12, and 14 go into evenly. That number is 420 is the smallest number. It is a very large number. That 10, 12, and 14 will go into evenly. Are you understanding the least common multiple? Okay. Everybody good with that? All right. Want to try one on your own? All right. 8, 10, and 12. Try that. I'll give you a minute to do that. It's the last problem.
People would run into it.
Nobody yet. Nobody yet.
That's how I'll probably
Okay. All right, what do we factor 8? Oh, okay. I'm just factoring 8. I didn't say for the answer. I just factoring 8. Andy, how'd you factor 8? Beautiful. Factor 10. Hannah. 12. Kendall. 4 and 30. All right, here we go. What do we got in common? 2. We got a 2, a 2, and a 2. Good. We'll cancel those out. So we got a 2. Anything else we have in common in all 3 of them? No. No, we don't have a 2. We don't have a 2 in the 10. We had one, but we canceled it out. We don't have another one. Okay, so whatever we have left, we are going to multiply together. So we have a 2 and a 2 over here. We got a 5. We got a 2 and a 3. You multiply all those together. What is the smallest number? That 8, 10, and 12. Fisher? That is correct, sir. The smallest number that goes into 8, 10, and 12 evenly is 240. All right. Any questions over 2 numbers or 3 numbers? Everybody good? Okay. In today's folder, your homework, you have something labeled 1-5 practice B. You are skipping number 17. Okay, you don't have to do 17. You need to factor them down. You need to use the exponential notation form or the Venn diagram form. Whichever one that you choose works for you.